Hey, everybody. Welcome. We still feeling full of energy here at the end of the second day of Ignite, the last one. Thank you all for skipping at least part of happy hour for this talk. I appreciate it. We'll grab some drinks with you all afterwards. As everyone else is filing in, I'll go ahead and just introduce myself and my co-presenter here, Raman. So my name is Chris Anderson. I'm a program manager working on Azure Functions from day one. So a lot of this stuff really just is kind of me trying to share the journey of how we've kind of gotten around to serverless. And then joining me is Raman, who is kind of really leading up and directing a lot of how we're talking about serverless and thinking about all the various serverless applications as we move beyond functions and how we're going to go ahead and work with people on that. So with no further ado, before we go ahead and talk about the present for serverless, I wanted to go ahead and just kind of really bring everyone to where we're at. Technology is all about this pursuit to really improve human productivity. And when we go ahead and apply that to cloud computing, we can really see that journey take fold within the things that we've seen in the last decade. We used to go ahead and build applications on premises. There was no, before the advent of the cloud, I essentially had to go ahead, find someone to go ahead and provision me hardware, find someone to go provision me servers on that hardware, provision my applications onto that hardware. So I had to solve all the problems that exist for delivering an application myself. And as we can see, there's a myriad of them, and lots of steps going on, lots of moving parts. And all of that is going to be counterproductive to productivity. We can't move very fast because we've just got lots of these various pieces. We need to go ahead and start to pull back. And so then comes cloud. Then comes IaaS. We could now go ahead and get a VM with a snap of our finger. You know, it wasn't necessarily like a full snap of our finger. It might have been like a couple snaps of our finger while we're waiting for it to finish provisioning. But it was still way faster than provisioning hardware. And you know, that just led to a burst of innovation inside of applications. People can argue that this current wave of startups that we're kind of in right now really exists because the cloud came to be and allowed folks to build applications as fast as they needed to keep up with demand. But as we can see, we still have lots of questions. It still is going to take a variety of different individuals, different roles in our teams to deliver applications. The more roles that we need to have, the more work, the more chores that we have to build our applications, the slower we're going to go. It stands to reason. And so then comes PaaS. And PaaS goes ahead and strives to go ahead and take one big swipe at infrastructure. We say, hey, you still have your applications, you still have your web apps, your web servers, et cetera, but you don't actually care about OS patching. You don't care about a lot of the nitty-gritty details of managing that particular VM instance. All you really care about is your web app you're hosting on there. And so we were able to kill lots of those questions, but we still are left with some, and none of those questions are related to delivering business value, really. They're all the chores we have to solve before we get to hosting the application. And so we arrive at today with serverless, where serverless really goes ahead and tries to reduce your infrastructure down to zero. We want you to only have to think about, how do I now architect my app for serverless? All of our previous conventions are based around this notion that a server exists. And while there is a server in the background somewhere running your functions, your Logic Apps, et cetera, it's not your server. It's serverless because you think about servers less. And so now all I have to think about is, how am I going to build my application to meet these new conventions that we offer to do serverless applications? So what is serverless? Well, first we start off with kind of addressing the servers, the server part of serverless. And it's an abstraction of servers. There's still going to be servers running your applications somewhere. Obviously, everything's still running on normal silicon. But our goal is such that you never, ever, ever have to see and manage a server. You should never even have to acknowledge its existence. The goal is that you just go throw something at the cloud, and it throws back at you all of your various responses for all of your various events. No infrastructure. Because there's no infrastructure, we have to kind of form a contract, you and I. How do we know when you need infrastructure then? If you don't tell us ahead of time how much you need, we need to have some kind of notion of how much to provision. And so that's how we get to the contract of event-driven. And we go ahead and strive to have instant scale there. So you don't even need to think about how long ahead of time before my event needs to be processed, do I need to go ahead and send it so that way I get it there on time? The goal is to be instant scale, so you are able to keep up with any particular traffic that happens throughout the day with those events. If I'm a ticket vendor and I'm selling things to concerts, and as soon as those things go on sale, burst of traffic, Serverless scales out to meet that demand. And as soon as those tickets are done selling, they're actually no longer being billed for me in that case. In fact, this event here is a great example of where Serverless is helpful. All of you are using the great Ignite application that we have here today with all of your looking up instances, marking our awesome talk on it, obviously. That's a great example of something where functions is very useful. It's going to be very, very popular for this whole week, and then the app's going to go dark. You might come back to it once or twice. They don't want to bring it offline, but they don't want to have it fully provisioned for the same amount of stuff. And they don't even want to have to do the pre-provisioning for this event in the first place. Serverless makes sense for those types of things as well. And then importantly, if you think about it, infrastructure is important from the point of view of what my application is going to run on, but we also have to ask a critical question when we're building applications, which is, how are we going to pay for it? We have to put time into thinking about what is the efficiency of our infrastructure to make sure that we're taking maximum utilization of our resources. But then we also have to pre-provision resources to deal with bursts of scale and all those sticky questions that come with how do I actually go ahead and get as little servers as I need to make my application work. And because with functions, we bill you on the 128 megabytes per millisecond, that granular of usage of our compute, you're only going to be billed for what you actually use inside of your functions. You're never going to ever have to worry about, well, is this going to be too inefficient as far as the function goes as far as billing? I'm able to go ahead and just be billed for the timeline of that particular function. And so what does this drive in our businesses? I get to manage apps, not servers. I get to move myself from infrastructure ops to application ops. I just have to worry about how my application is behaving. The infrastructure is taken care of by Microsoft. I can be sitting on a beach, and all I got to do is worry about making sure my application still returns 200. If there's an issue, you file an incident. I wake up in the middle of the night, and I make sure that it gets fixed. And so to that very point, you don't have to wake up, mostly. You can always have an issue where some downstream resource might be unavailable, things along those lines. This isn't the end of ops. No ops is a lie. You're always going to have to make sure that it's running. As long as you have an application, you're going to have operations. But you're never going to have to worry about patching going wrong, updates somehow not fully sticking, it not scaling out for some reason. That's all on our platform. All you're worried about is my application still behaving nominally. And all that leads to a faster time to market. That's what really matters. That's why we did the evolution from on-prem to the cloud. It's not like we like giving up control over our servers on principle. We like not having to pay the tax of having to do those chores to maintain the infrastructure, because that tax costs us more to deliver our applications. Our businesses are driven by how fast we as developers can innovate behind them. We need to go ahead and move as fast as possible in order to meet those demands, which is why serverless is going to push the next wave of innovation in the cloud. The businesses which adopt serverless today are going to be the same businesses that adopted IaaS when it first came out and are now outpacing their competition, and everyone's in a race to get to the cloud. So serverless, as soon as possible, really helps you really take advantage of that agility.
Can you guys hear me?
Try again.
How about now? All right. Good afternoon, everyone. Very excited to be here. I'm going to try and explain to you why exactly it is that Microsoft would just not stop talking about this serverless thing, whether it is the CEO of our company or just measly product managers like Chris and I. The concept that that joke worked much better in my head, by the way. The concept that I want to talk about is that of a platform, not an individual service, but a collection of services that you can use together to construct fully serverless applications. So I want to start doing that by talking about some of the services. So let's talk about Azure Functions to begin with. How many of you know about Azure Functions? OK. It's an impressive percentage, I would say about 70% of the people. So when we talk about serverless, it's very obvious and very natural in some ways that we talk about functions as a service. The whole concept of being able to execute custom code on demand without having to worry about where that code is executing And how would you worry about scaling it if the demand goes up? That's what Azure Functions does for you. Now, there are other capabilities that this service has, and we'll get into the details later on. But for now, when we talk about the platform, that is the important bit to remember about Azure Functions. So moving on, we have Azure Logic Apps. How many people know about Logic Apps? OK, slightly fewer, I think I would say 30% to 40% people. Not many of you would probably know that Azure Logic Apps was actually introduced before Functions was. So in many ways, it is the original serverless service that we have. And I want to talk about why this service is so important for us and for building serverless applications. So imagine you're drawing a flowchart that represents a certain process inside your organizations. And this process could be when a new customer record is created in your CRM database, go ahead and create a corresponding project in your project management system. And while you're at it, send an email notification to these 3 designated people. We all have processes like these inside our organizations, almost on a daily basis. Now imagine you could, with a few simple clicks, convert this flowchart into a real application which actually performs those actions. Now this is what Azure Logic Apps allows you to do. It provides you a visual design experience using which you can create workflows with multiple steps, and each step could be a processing which is being performed by either a Microsoft service, whether an Azure service or an Office service, or even a third-party service, whether Twitter, Slack, Facebook, any of those services. Or you could even be orchestrating some Azure Functions, serverless code that you have written for yourself or somebody else has written for you, and you want to utilize them inside your business process workflows. That's the power of Logic Apps. So in many ways, it is not only serverless, but from a user experience perspective, it is also a codeless experience. So we'll be doing this less thing a lot. So less is the new more for us. So moving along, that one also sounded much better in my head. Moving on, let's talk about Azure Event Grid. How many people know about Event Grid? OK, far fewer. And that's obvious because it's a new service. We announced it only last month. It's still in public preview. But we believe this is a very, very important service. And the reason for that is because our fundamental belief is that the whole popularity of the new on-demand, elastic scale compute services is because of how modern computing is all about events. And something needs to be done to respond to these events, whether it is executing some custom code or executing some logic that you might have built, but these events need to be handled, which is why all these serverless computing platforms came along. But what about the events themselves? How do we manage those events? And that's where Event Grid comes in. So Event Grid provides you a single, simple interface for managing all your events. And that management could mean managing where those events are coming from. Is the event happening because something changed in your database? Is it coming because something happened inside your storage? A new user got added to your cloud subscription? Or a resource got provisioned in your cloud environment? All of these are events which you potentially need to handle in some way or the other. And then the second part of managing these events is, what exactly are you going to do with these events? Who's interested in these events, and who's going to act on these events? So it could be some custom code through Azure Function running serverlessly in the cloud, handling that event and doing some processing on it. Or it could be a logic app. Or it could be even some other endpoint that you might have created for yourself. So we believe that for modern apps, an event is an important enough entity, concept, that it needs to be a first-class citizen inside the Azure universe. And that's what Azure Event Grid does. So we're going to talk more about this service later on, but these are the basic concepts that we have. Now, these are the basic blocks of beginning to build serverless applications. What do you do next? Your applications do not run in vacuum. They do not work in isolation. Your applications need to talk to databases. They need to store files in a storage. They need to perform some kind of, they need to provide some kind of authentication mechanisms. And if there are IoT apps, they likely need to exchange data with the IoT devices, whether it is receiving data or sending back data to those devices. And it could potentially be enriching the data coming from these devices and preparing it for some analysis that you might need to perform for some other operation inside your business. And also, more and more applications these days are required to have some kind of intelligence built into them. How are you going to do all those things? It would not be fun if your application code was running in a serverless environment in the cloud, and then in order to utilize all these other things, these building blocks of all applications, you had to create, manage, and provision an army of virtual machines. That is exactly the opposite of fun. So you actually want serverless services that provide you all these functionalities, and that's what Azure does for you. So for databases, we have Cosmos DB, that you guys might have heard of in this conference, which is a globally distributed elastic scale database, a perfect ally for your serverless applications. For storage, we have Azure Storage, a fully managed service. For providing security and access control, we have state-of-the-art tools like Azure Active Directory and Azure Active Directory B2C. We have IoT Hub that not only allows you to exchange data with IoT devices, but it also allows provisioning of those devices in a manner. And then for analytics, we have services like Event Hubs and Stream Analytics that allow you to ingest and analyze real-time streaming data. And for intelligence, we have Microsoft Cognitive Services API that you can readily utilize from within your code or from within your logic inside Logic Apps. So these are all different services that come together and create a platform to allow you to build fully serverless applications for which you don't have to worry about any infrastructure, you don't have to worry about any scale, and you pay only for what you utilize. You don't pay for any idle capacity whatsoever. OK, so that's about a platform on top of which you will build your apps, and on top of which your apps are going to be hosted in the cloud. But what about the process of building those applications? How does the developer experience look like? So how many people listened to the quantum computing discussion yesterday with Satya and his friends? OK, so between them, they had a combined IQ of like 5 million, and they were talking about things that I completely understood, as all of you did. But the thing that strikes me the most was the fact that quantum computing is still a work in progress. But what has already arrived is a developer experience for quantum computing. There's a programming language for it that you can work on within Visual Studio. There's a developer experience for it. And that should tell you something around how Microsoft feels about the whole developer tools and the developer experience story for anything that we create. Cloud is no different. Even in the cloud world, especially the serverless world, we do not subscribe to the mentality that just because you're reaping the benefits of running your application in the cloud, the process of building those applications should be filled with pains and heartburns. We feel that you should get a fully end-to-end developer experience through the best tools available out there in the market. So for building serverless applications, we provide full end-to-end developer experience through world-class tools like Visual Studio and Visual Studio Code. In fact, we provide really unique functionality, like being able to build serverless applications and test them and debug them locally on your own machine before they are even deployed to the cloud. This is something that I would say massively boosts the developer productivity while building cloud applications. And it also is something that none of our competitors can even match. So developer productivity. Secondly, all of the things that we do in terms of serverless application development are very DevOps friendly, which means that you can integrate all of these things into your existing deployment pipelines. And we also have tools like Azure Application Insights, which provide great support for you to monitor your serverless applications when they're running in production. So the full gamut of different services, whether you're building them, whether you're debugging them, whether you're monitoring them in production, all of the developer tools that you would otherwise use for other applications are also available for serverless applications now. Full experience there. OK. So with that, I would like to hand it back to Chris to do a demo and show some of these services in action.
Cool, everyone. So I'm glad that there wasn't as many hands up for Event Grid and Logic Apps. Well, not glad. Hope that you all raise your hands after this for the next time that we ask this question, because I'm going to show you an example of how we can go ahead and use Event Grid and Logic Apps to basically automate watching any changes that happen to our Azure resources via ARM. Azure Event Grid has an integration with Logic Apps, so I can go ahead and trigger a Logic App every single time that an event happens on Event Grid. And it comes out of the box with the ability to go ahead and create subscriptions. So in this case, I have a subscription for my Azure subscription, which is called Antares Demo. My resource type for this is going to be looking at resource groups. And in this case, I've pointed it at the same resource group that my Logic App is in. So in fact, every single time that I save my Logic App, it's going to go ahead and send a message to the Logic App about how it just got saved. So it's kind of fun. It's hitting itself. I like building those types of demos where we kind of exercise this service with the service. And what I'm going to do with that is push that into Teams. There's great integration here to reach out to hundreds of services. I think we're at close to 180 connectors for Logic Apps. And so with that, I'm going to go ahead and be able to talk to really any service that I need to most of the time. And even if I can't, I can always throw a function in there and have the function talk to the service for me. So we're always covered there. The problem with this is it's a little bit simple. Hopefully you all can read that. But even if you can read it, you probably can't, because it's just a pile of JSON. In this case, I was too lazy, and I just dumped the body of the message straight into the Teams thing. And just to give you a nicer view of what that JSON object looks like, this is what the message is that we're getting back from Event Grid. So this is just a JSON object. It's got a bunch of data in there about what we actually touched, what was going on. We have the actual claims object that we can go ahead and parse through there and understand who touched the object. And so what I want to be able to go and do is parse that object, really figure out more information about what was going on, grab who touched what when, and then spit that out to Teams, because that's more useful. And I wanted to add some custom rules. Touching and modifying things is OK. Like, we want to see those events. But what really scares us is when we do deletions. Deletions are a very irregular thing for us in this particular service, just because I'm making it up and I can't say that. And it scares us because data loss scares us, and no one ever likes having to deal with that. So every single time that someone goes and tries to delete a storage account, I want to go ahead and have a big warning message appended to that thing, so that way I'm aware something bad might have happened. We should go and blame this person. So what we can do is I've got myself a function that I've already created for us. It's already pre-cooked out of the oven, just because you don't have to watch me type JavaScript in a portal live in a demo. And in here, I'm going ahead and get my request in. You can see here that I'm able to get the body of that request, which is going to be that JSON object. And then in this case, I'm also going to log this out here to the console. So you can see here when I run this, that I'm getting that JSON object that we just saw there in our console window. So collapse that back down. So what I'm going to do is I'm going to go and parse out the JSON strings that were deeper inside that JSON object, because they were strings, not JSON objects. I can just call JSON parse like this. And then I'm going to do my piece there. One other fun thing is every time Event Grid sends a message, it also creates an ARM event. So every time Event Grid creates a message, it creates an Event Grid message about how it created an Event Grid message. So also kind of fun. So I'm going to go ahead and just list those as ignore. I don't want to see that Event Grid created an Event Grid message. It doesn't interest me in this particular case. But I do care about the fact that in case that there was a delete operation, I'm going to go ahead and set verbosity to warning. And then I'm able to go ahead and send data back to the Logic Apps by just going ahead and setting body to being the contents of what I want to send back, just a regular JSON object. Very, very simple, straightforward, write a little bit of code. I even did this in the portal, but you can always do it locally. I'll show a demo of that at the end of this presentation. And I now have a function which I can go plug into my Logic App. So from there, I'm going to go ahead and click on Add an Action. And you can see here when this is going to go and look up all the actions. There's a lot of them. But in this case, I'm going to use Azure Functions. And I'm going to choose an Azure function to go ahead and trigger in this particular case. I'm just going to go index all of my functions. This can take a little bit of time for this particular demo, because I probably have 100 function apps. And so it's just going through all my resource groups and finding them. But once it finds them, I can then select my function that I just had. So I'm just going to go and sort down here to Shrande MS Ignite. And I can see here that I just got this HTTP trigger JS1. I didn't make it a very smart name. I just kind of used the default name. And then in here, I can go ahead and just pass the body directly to the function. And then boom, now I've got my function going ahead and processing each one of these messages, and it's going to send me back a response. One thing that's really useful is, while I can just use that response directly using the functions that Logic Apps supports inside of it, I really want to parse that content into a JSON object so I understand what was in that body. So Logic Apps has this great ability to go through and actually process data. So there's data operations parse JSON. Click on that. And then I'm going to pass that the body that I got from the function. And then in order to generate the sample schema, fortunately, I'm able to run this in the portal and see what the output is, which is this lovely object. Oh, this is the request. I want this. So I'm going to go ahead and take an example response that I got from the function app and just paste it into here, and it'll generate a JSON schema for me. So now I'm able to use all those objects that I got from the function app directly without having to guess that they were the right form. So now the next thing, I want to ignore all of my event grid type messages from event grid because it was just noise for me. So I'm going to go ahead and add a condition. And so I can go ahead and add an if statement inside of here, and I'm going to look to see whether verbosity is going to be equal to ignore. And if that's the case, I want to do nothing. So I'm just going to leave this if true is blank. And then if it's false, I'm going to go ahead and do teams. And I can click and drag this thing into the if statement, so that way I don't have to delete and recreate it. I can just click and drag things around inside the UI. I can even reorder these things if I wanted to by clicking and dragging. But just take my word for it. I don't have a good example for that. So hit save. And then the funny thing is, by saving this, I'm going to create a message, and that's going to spit a message out to my Teams channel. And it can take 1 or 2 seconds, depending on, it's going to save, it's going to tell ARM, ARM's going to then tell event grid grid's then going to tell Logic Apps, and Logic Apps is then going to run and send it to Teams. So it might take 1 or 2 seconds, but that can be relatively fast. The other thing I wanted to do was just show you an example of me then deleting a resource. So I'm going to go ahead and choose this sacrificial goat storage account that I've created called Sharonde Will Delete Me 123. Very useful name. And I'm just going to delete this. It never had any actual data in it, so don't worry, I'm not actually doing anything harmful. Well, besides making bad jokes during a demo. And then that will now go ahead and create another ARM event for me. So if I go back to my Teams channel here, and I'm lucky because the Logic App would have fired by then. Let me just make sure that it's actually enabled. Yeah, there we go. I can actually see that we get triggered here. And the nice thing with Logic Apps is even if I'm not sure whether that event triggered or not, I have my full history logs here. So I go ahead and look at every single message. Every single one of those steps, I now have a visual thing to look through and to see what it did. So in this case, I can see all the body that was sent to me originally. I can see the output of the if statement. So in this case, it rendered false. And I can see that it actually succeeded to post to Teams. So it thinks that it posted to Teams. So maybe Teams is just learning a little bit slow. Just change between my windows here. And maybe I just need to scroll down. I haven't seen Teams actually fail to refresh this much, so just call that fun demo internet. So I think in this case, we won't wait for Teams to show up. We can see that Teams actually thinks that it succeeded. Maybe my internet is just slow and it's not actually showing from my Teams channel here, but normally it just kind of dumps right into there. And before I switch away from that, I just wanted to go ahead and emphasize again just how many connectors Logic Apps has, especially for this audience. You can see here that's my delete one that just came up there as well. I can go ahead and have this dump into lots of different places. So let's say that I chose a different thing to send this to, like sending an email to myself because Teams is slow, and I could have used Teams in this particular case. Not that I meant to imply Teams is always slow. But I've got the ability to go ahead and send an email. They've got integrations with things like Twilio and SendGrid if I wanted to use those instead to send messages. I can go ahead and send data directly into Power BI, so I can go ahead and immediately have visualizations of my data in real time by using Power BI streaming data sets. I can do all of this without any code at all, except for when I need just maybe a little bit of code to go ahead and parse data in a way that I don't want to have to do myself. So yeah. Oh, that's actually, I know why this didn't send a message. We were just sending the body still. So I didn't go ahead and copy this. So in this case, I wrote a relatively complex expression. Logic Apps lets you go ahead and write very complex expressions via this add dynamic content section in their UI. If I zoom out here, you can kind of see. But in this case, I didn't want to go ahead and watch you guys have me click around and type that in that little portal, so I just copy-pasted it. So now I should be able to go ahead and hit OK. There we go. Then hit save. And then this one probably will actually send to Teams because you can see that the timestamp's actually updated here. I just wasn't paying attention. And so now I should be able to go ahead and get my message back from my Logic App with the formatted text. But I should have practiced my demo one more time or something. So with that, let's go ahead and move on to the rest of the presentation here.
Oh, there it is.
Oh, yeah, it showed up? Yeah, there we go. Wait.
Now, we need to switch back now.
I have to have this for myself, not
Evidence.
for you guys. There we go. Don't reward me. All right.
But still practice more.
Yeah. Near's taking notes here.
So that was an example of changes happening in Azure resources, and then all the three services that we talked about, Event Grid, Logic Apps, and Functions, playing together to purify, the logs coming in from those events, and then passing them on to a different destination, which is Microsoft Teams. So, but what are some of the other scenarios that make sense for serverless architectures? It's not a trick question because the answer is right there. It says anything that needs to respond to events. And if you think about it, we already mentioned how important events are in the modern application arena. This definition covers a huge portion of the computing landscape that we have today. So let's look at some concrete examples now. Real-time stream processing. You could have multiple IoT devices which are sending data that needs to be collected, analyzed, and then archived. So this is a good example for building using serverless technologies because you don't know when the data is going to come in, and you don't know how much data is going to come in. So if you were going to build this application or this scenario using traditional ways, you would always have to build for peak capacity, whether or not that peak capacity is utilized most of the time. Most likely, it will not be utilized. So if you go with a serverless architecture, you would be, like, the cloud would be provisioning the necessary amount of resources to perform this task for you only when they need it. And you pay only for when things are actually getting used, rather than paying for idle capacity. Timer-based processing. This is, again, a good example of something that happens almost in every organization. Like, everywhere we have scenarios like something needs to happen on a regular cadence, and it happens for a very small amount of time, and then goes away. For example, dedupe some database entries at the end of every day, or collect some server logs at the end of every week, and then collect them together and collate them. So things like those, why would you want to stand up dedicated infrastructure or VMs or servers to perform that functionality, which happens relatively infrequently and stays only for a very small amount of time? Serverless is a perfect sort of a solution for doing these kinds of things. Just create a serverless function, do that processing within that frame, and then let it go away after the processing is done. Building backends for your mobile, IoT, and even web applications is also a very popular use case for serverless technologies. And in this specific case, you see a mobile application which is actually sending an image to an Azure function. The Azure function takes that image and puts it in cloud storage, Azure storage in this case. And this action actually triggers off another function. And this other function takes the original image and creates thumbnails of different sizes from the original image and then stores them somewhere. So this is the kind of a functionality that many mobile apps need these days because they're dealing with images, they're dealing with a lot of data that user is providing them. But you notice that most mobile app developers want to innovate and focus on their client applications and do not necessarily want to worry about how to stand up an infrastructure, how to create services that run their backends. So this is a good example and a good scenario where you could just slap together some functions or some function and logic apps together and create a very robust backend for your mobile applications. A good example for where you get to focus on what you want to do, your business results, rather than worry about logistics. And lastly, bots are all the new rage. And if you think about what bots do, they take a question or a command or a request, they do some processing on it, and they send back a response. And now this processing is basically what it is doing is it is taking the incoming request, which essentially is an event. And we don't know when that event is going to happen because it is non-deterministic. So why again would you want to create dedicated infrastructure and resources to be able to fulfill this scenario? This is a perfect example of processing that can happen within the context of serverless technologies like functions or logic apps. Now, I want to spend a little more time going into a little more detail of the capabilities of the core 3 Azure services that we talked about, beginning with Event Grid this time. And the reason we are beginning with Event Grid, although it is the last service to come in our toolbox, is because we believe it all begins with an event. Like an event comes in and then something happens. Where do you do the management for those events? And that's the problem that Event Grid solves, actually. It provides you a single interface for managing all your events. If you look at this diagram, it shows you there are multiple sources from where the events can come from. It could be storage, it could be resource groups, event hubs, or you could create your own custom events on which other subscribers can listen on and react on. Similarly, you see there are multiple destinations to which these events can be routed. It could be Azure Functions, Azure Logic Apps, automation, and even generic webhooks that might want to respond, that might want to subscribe to certain events and then do some custom processing on it. So this rich set of publishers and subscribers on both ends will actually give you very interesting scenarios that you can already think of that you can implement inside your workloads and your solutions. And our promise is that this lift is only going to grow. This service is about a month and a half old, and we already have a bunch of services integrating with it. As we move towards general availability, there'll be a whole new set of services, both from within Azure and outside of Azure, that come in as both publishers and event handlers, further increasing the possibilities that you can have and exercise with this service. And in terms of performance and scale, Event Grid makes some really strong promises. Sub-second end-to-end latency in the 99th percentile, which means as close to real-time delivery as it gets. Secondly, almost 10 million events per second, which means massive, massive scale. And thirdly, an intelligent, adaptive algorithm to figure out when to retry if the first event delivery is not successful. So all of these qualities make Event Grid a really powerful backbone for your serverless applications. Moving on to Logic Apps now. So we already saw Logic Apps in action with some glitches. Logic Apps provide you a visual design experience for creating cloud workflows without writing a single line of code. No matter how complex your logic is, no matter how complex your process or workflow is, you can always represent it using the powerful control flow available in Logic Apps. And the best part about Logic Apps is the multiple connectors that it provides, whether it is to Azure services, third-party services, or even orchestrating some functions that you or someone else in your organization might have written. The functions that you write can act as steps, as Chris showed earlier, inside your workflows, and they can do custom processing, which is not readily available as standard connectors in Logic Apps. And lastly, all of these workflows, the internal representation of these workflows is through a declarative definition format, which means that these are things which are not these are not toys. It's already very friendly with your existing CI/CD practices, and you can easily integrate your Logic Apps into those processes. I think Chris already mentioned that number has changed from 170 to 180, so within the last 5 minutes, we have already made great progress. But Logic Apps, the number of connectors that we have is pretty high, 180 now, and the list will continue to grow. As you can see that we provide integration with a bunch of Azure services, whether it's storage, functions, and many other services. But you'll note that we also provide integration with many interesting third-party services like Dropbox or Twitter or Slack or Salesforce. And the best part of using these connectors with Logic Apps to build your application and workflows is that you never have to deal with any of the authentication, any of the SDK or API or specific communication protocols for those services. You just click, plug and play, and you start using those services so that you can focus on the problem that you are trying to solve, not on learning the specifics of a service that you're going to use only for one step. And now to talk about functions, I want to call Chris again. He's been working on functions before functions was functions, so there you go.
So one of my claims to fame on Functions is I actually got to design the logo. And the way that we approached designing the logo was Microsoft, as we always have, has some group of people who describe what are our symbols for various things. We have a symbol for code, we have a symbol for events. And so as we were going through all of our various iterations on what could we do, I said, well, let's just slap the two together. And so Functions is just that. It's exactly what's represented by the logo. Functions is code reacting to your events. More than that, it's built on top of the platform that we had called Web Jobs. How many people in here have used Web Jobs before? So Functions is an evolution of Web Jobs. And Web Jobs obviously still exists, and it's still being developed. And we've built Functions as basically a fully managed Web Jobs platform. Just Functions was a better brand than Web Jobs, so we called it Functions. And what it's designed to do is make it as easy as possible to write some code and have it react to events, is what Web Jobs is trying to get to in the first place. But what we're able to do with Functions is dynamically manage your scale, pay per execution. We've built monitoring deep, deep, deep down into the platform so we can understand every little thing about how your functions are behaving. And we're able to do just lots of things to make it as fast as possible to get you writing some code and have it running in Azure at the scale you need it to scale to, whether that be something very low or something very high. And of course, functions are only useful if we have all the events that you want to go trigger to, and that when you talk to those events, that they're of the type that matter to you. When we're going ahead and processing your event hubs, we're going ahead and processing each partition in order, so you can still have ordering guarantees when you're processing event hubs. You have access to the real storage objects when you're working with storage, so you don't have to go ahead and just get a little piece of metadata and shove it into a storage SDK yourself. We go ahead and give you the full objects. And all of these things are really designed to make it as fast as possible for you to go build something and write. Really what we're trying to do is make you write the least amount of code, too. We have nothing against writing code. We love code. But code has cost. And we're really trying to reduce what you have to do to just business logic. No managing of any other pieces if we can. And so just taking a look at the serverless application platform again, what we've recently done with Functions just here in the last week we announced, so we have a couple of fairly big things. You can now deploy Functions locally on Linux, Mac, and Windows. So now all of you who do have Mac and Linux devices, or those of you who have both like me, you can go ahead and use whatever machine you want to, and it'll work the same on both machines. This also means that we have support for .NET Core 2.0 out of the box in the latest beta version of Functions. Our baked-in monitoring with App Insights is now GA. So now you can go ahead and use the App Insights integration for your production applications and have lots of expectations that it works just the way you want to. This feature has been great for me, and it's great for you too. But it's been great for me because I really want customers to be able to go ahead and figure out what's going wrong with their functions when there is something that goes wrong with them as quick and as fast as possible. And with App Insights, their various tooling, monitoring, great analytics portal, it's one of the fastest ways to actually go ahead and monitor and manage my applications. And of course, one really big piece of news is that I can now trigger Azure Functions on the Cosmos DB change feed. So now everything that happens inside of your Cosmos DB can then have a subsequent function, which is triggered, and it's passed the full document from that particular change to the function. Even if it's changed since then, you'll get the document as it was changed at that time. We've gone ahead and done built-in integration with our portal UI and Office in order to go ahead and get you a Graph Office token to talk to Graph APIs out of the box. So you no longer have to do any weird provisioning of like a create your own service account, essentially, to go ahead and talk to AAD. Service principal, thank you. To talk to AAD, now it'll go ahead and be managed for you automatically under the covers, and it's just portal UI. You click, it's provisioned, and it's managed for you for the lifetime of that particular account. And now you have the ability to also trigger a function from Stream Analytics. So as I'm going through there and looking at data coming off of my IoT hub for various extraneous events, I can now have it directly trigger a function, not have to go ahead and add like a queue between the two of them. They'll just go directly to the function itself, which means it's just faster for me as a developer to set up that pipeline. So with all those new capabilities, there's going to be all kinds of great new scenarios that come from all of you, and you'll hear a lot more of that stuff coming out from us. But with that, I want to get into a very fun demo, a demo I'm looking very much forward to doing. In another life, if I hadn't chosen to be a developer, I might have decided to want to be a game show host. And so what I want to do now is, I think we have some volunteers here to come and be our audience participants. Can they come up on stage?
Thank you for volunteering. There are
Thank you very much, yes.
Yeah.
We've got prizes for you.
Come on.
So what I've got here is I've got some IoT buttons. And I've gotten them connected to Azure, so when I press the button, it's going to drop a message into a storage queue, essentially. And then that is going to then drive the process of reacting, voting, and playing the game that we're about to play today. So participants, this button, you can press it once, or you can double-click it. What you're going to see here on the screen down here is an answer on the left and an answer on the right. For the answer on the left, you press one click. It says one click under the thing to remind you, or 2 clicks for the answer on the right. You can answer as many times as you want to, so if you feel like you got it wrong the first time, you can answer again. But there's points for the first people who answer. I remember the order of the answers as they came in, and if you change your answer, I change your order. So you get 4 points for being first, 1 point for being last, but 0 points if you get it wrong. Make sense?
And needless to say, this has been built using serverless technologies.
So your identity corresponds with your button. There's about a second lag, because I'll tell you a bit about the lag. But the secret is essentially it's running locally, so there's a kind of thing going on. And then those things are talking to my phone, but they should work. I've tested it all around this room. They have range. So let's go ahead and play. Hope that you have read up on, you've been paying attention. So what is one of the primary benefits of adopting serverless technologies? Is it 1 click, building app faster without having to worry about infrastructure, or 2 clicks, kudos from coworkers from using technologies with cool names? Cool, we've got all of our answers in. So obviously that was just an easy one to get everyone ready to get into the system, okay? So let's go for another one. Serverless means only functions as a service. 1 click true, 2 clicks false. I should try and be making noise, because the buttons technically make noise as you click them, so I'm sure you can hear your fellow teammates. So there we go, okay, so like, hey, we're learning something here. That's good. Which service provides a no-code experience for building serverless workflows? Is it 1 click Azure Functions or 2 clicks Azure Logic Apps?
Oh, hold on. Yeah.
There we go. Cool. Most people got it right. Which database is elastically scalable and planet scale? Is it 1 click Cosmos DB or 2 clicks Microsoft Access? The rest of you have been hearing the marketing today, maybe? OK. I'm required to say that 3 times in this presentation, so I think I'm at 2. All right.
Access.
It's definitely Access, no. Which service is newer, Azure Logic Apps or Azure Event Grid? OK. And what is the best way of getting started with Azure Functions? Just waiting till I'm told to change, or AKMS/try functions? OK. Great, we've got our winners. Number 1, green. Number 2, blue. Number 3, black. Number 4, white. Who is green? So I'm going to just you're all getting a prize when I hand them out in order, so you get bragging rights. We got blue. Who's blue? There we go. Yeah, that's blue. It's pretty blue to me. Black. And we've got white here. And I'll trade you guys for the buttons. No, unfortunately, I didn't bring in extras.
Would you like to thank your fans and family?
So thank you, everyone. Give them a round of applause for being up here. If you guys want to, you can grab a T-shirt on your way out. They'll also be available for everyone else later. So the point of that wasn't just to do a goofy demo as much as it makes my heart sore that I was able to be a game show host. This is all running on functions. And the reason I had it full screen was I also wanted to just point out here, it might be kind of hard to see, this is actually running on just my local host. So I'm able to go ahead and run functions locally, even though it's called serverless and it's all supposed to be running in the cloud. Because Azure Functions itself is open source and we've built all of our stuff to just kind of be movable, I actually have the ability to just run it locally. So if I look here, I can see this thing's going really quickly because I'm just polling right now locally to go and get my responses. I could probably do that more intelligently. And every time I press the button, what's happening is it's going ahead and listening on the thing. And then it's sending me red text because when I press the button after the game is over, it likes to yell at me. So now if I press the button, it should be happy again. So there you can see that I'm able to go ahead and trigger this thing as much as I want to with just this fancy button. The way that it's working is that function is listening on a queue. And these buttons are, via my phone, sending a message to an Azure storage queue. And so even though this thing's running locally, I'm able to listen on Azure queues and still react to those particular events. One other nice thing that's able to happen because I'm running locally is I can go ahead and, let me just make sure that this is all set up right. I can actually go ahead and connect and debug locally. This is great because as much fun as it is to debug with console log, it's much more fun to go ahead and attach a breakpoint and go ahead and explore the object. So in this particular case, I can even go ahead, and this is full, just normal Node.js debugging inside of VS Code. Inside of C#, it's the same thing. I can go ahead and F5, attach a breakpoint, and it just works. And I can see all the full objects. I can edit these things if I want to. And it's just a normal server-full development experience. But then I can go ahead and deploy it in serverless and then forget about it. So even though I'm having to move away from doing servers, I'm able to go ahead and keep the tools, the experiences that I'm used to using as a developer. So one other cool thing I'll just point out, and then we can move on to the next piece, is this UI is all kind of shrunken. But these are just multiple functions all in the same project here. So I don't have to go ahead and treat each Azure Functions as independent. I can go ahead and deploy a collection of functions all as one unit, all with the Azure Functions command line tools. If I go over here to our fancy thing here, I could very easily go ahead and do func Azure function app publish, and then type the name of my particular function app. And this would go ahead and publish all of my code up to Azure without any other particular hullabaloo. I can also web deploy. I can also listen on GitHub. I can also listen on Bitbucket. I can also listen on VSTS. Any way that you want to deploy, you're able to go ahead and do it with functions without having to go ahead and set up a lot of fancy scripts. So it's just that easy. So with that, let's go ahead and wrap up.
Thank you, Chris. And while we wait for that scenario to turn into a real customer story, I want to talk about some real customer stories that we know about. Many of our customers have seen success with serverless technologies. I want to talk about a few of them today. First one is Fujifilm. So Fujifilm had this huge image management and sharing service, which was handling almost like a terabyte of data each day. And then the problem with the service was that it was a monolithic service, which means that any changes they wanted to make, any enhancements or any bug fixes, they always had to do it in a way that used to disturb or cause problems for the production service. And in addition to that, as more data was being handled by the service, the latency of this service was actually worsening. So they used serverless technologies like Cosmos DB and Azure Functions. And by the virtue of using Cosmos DB, they saw that the latency reduced by 95%. So it is not excess, it is actually Cosmos DB. This far exceeded their expectations. And of course, since they did not have to spend time in infrastructure management and provisioning, all that saved time went towards development, which was the core activity that they wanted to do anyway, which was the thing most aligned with their business results. So they could cut down on development time by 75%. But the most interesting result that they saw was that by the virtue of building multiple Azure functions that they can stitch together, they were naturally led towards a microservices architecture, which means that they could come out of the monolithic mode and build a microservices architecture-based service so that every time they need to either fix a thing or introduce some new functionality, the entire service does not need to come down, which means higher uptime and reliability, and much faster process of adding new functionality. So great benefits for Fujifilm there. It's not working. Oh, there it is. Go back. Yeah. The second customer I want to talk about is Quest, which some of you might have met in the expo hall. Quest have a solution for managing the Office 365 and Azure AD environments for their customers. And they've built this as a SaaS, software as a service application, completely on top of Azure serverless technologies like Functions, Cosmos DB, API management, event hubs, and so on. And this saw regular benefits that most people see with serverless technologies, which is faster time to market, faster time to revenue, lower costs of running their operations. But the most important benefit that they saw was the ability to scale much higher than they could earlier with their previous architecture. They're now able to handle millions of objects at the same time, which is something that they could not achieve with the previous architecture that they had. And the last example that I want to talk about is a very interesting one, Plexure. This is actually a company based out of New Zealand. They use technologies like IoT and machine learning to capture a lot of signals from retail users, and then they use all this data to provide, to allow their customers, who are retail companies, to fine-tune their marketing and targeting efforts around retail users. They've built this entire thing on top of our serverless platform, Cosmos DB, Azure Functions, Event Hubs, and of course, IoT and machine learning. But the best benefit that I feel that they've gotten out of using serverless is that they have provided a great extensibility story for their solution to their customers, which means that earlier they had to build custom functionality for each customer, and that used to take them a lot of time. Now they are able to just expose an interface to their customer in which their customers can drop in some code, which actually becomes an extension of their service.
And that's actually one of my favorite stories of all of our customer stories, because that was a great example of someone who just, they were writing just tons of just random connectors for all their various customers, and one of their engineers just saw functions that build when we released it 2 years ago, and was like, let's just try this out for writing these APIs. And that seemed like a lot of fun. And then they discovered that we had open sourced our portal UI, and then that led them to just kind of keep on going and really start to move towards doing just great big things. And so that's a great example of how for all these customers with functions, it's kind of a slippery slope. They just kind of started with one little random thing, and then they discovered it was useful for everything.
So yeah, so not only they build their own solution with serverless, but they allow their customers to bring in their functionality, which is executed by them, but in the context of their customers, again, on Azure Functions. So this is like serverless in serverless. This is like the geek version of Inception. So not only cost and effort improvements, scalability improvements, but great extensibility story using just serverless technologies. So that's it from us in terms of the presentation. If there's one slide that you'd probably take a picture of, this one should be it. It's a list of other serverless sessions that you might be interested in. And at the bottom, there's a very easy to remember link, azure.com/serverless, which talks about all the different serverless services that we have in our arsenal. And Chris and I will be here. If you have any questions, feel free to come over. And
if there's any questions, just please try to use the microphone in the middle. We have T-shirts up here up front, so anyone who wants to grab a T-shirt before they leave, feel free to just walk up here and grab a T-shirt as we're going along. And we've got lots of stickers and other swag down at the booth. So if there's any questions, feel free to just speak up and ask on the microphone. We'll go ahead and try to handle this now. Thank you.
Is there a limit?
Can we put the mics on?
Is there a limit on how complex a function can be? Most of the demos are simple modules. Can I deploy something with a custom class library?
Absolutely. In fact, the latest Visual Studio tooling for Visual Studio 2017 is actually just a class library with attributes, and we have a custom build step that goes and generates all the config files you need for Azure Functions. And so in the latest version of Visual Studio, it's just a normal, standard, out-of-the-box class library. You can run XUnit tests against it, all that you want to do.
Cool.
Any other questions here?
Yeah. On the case of Plexure that you mentioned.
use the mic, please.
On the case of Plexure that you mentioned, do you have more info about how they implemented functions in a way to extend it through, to allow customers to extend and consume their?
The short answer is that you can use each function app as essentially a tenant boundary, and so they will let each customer basically keep on adding functions to a particular function app, and then they reverse engineered our portal APIs and things along those lines to basically make our portal UI show up in their portal UI with their own custom skin on top of it. And mostly that's thanks to the fact that our portal UI code is all open source, and so it was really easy to just kind of grab in there. It's actually just an Angular, like an Angular 2, now Angular 4 project, and they were already on using Angular 2, so it was really easy to just move a component over.
When you say the portal UI,
The Azure Functions, the stuff that shows up inside of the functions part, that's all open source on GitHub.
There's a functions experience inside the portal.
Yeah, if you just go to github.com/azure/azure-functions, that's a link to all of our GitHubs that we have for functions. The runtime, all of our bindings, all of our samples, all of our portal UI.
When are you targeting GA for the event grid?
Do we have an answer from Ram if he's still around?
Yeah, it'll be early next year. Soon, yeah.
Anything else? Yes, I mean, there's lots of things that come into securing.
Chris, could you repeat the question?
The question is, how do I secure my Azure Functions? There's lots of things that go into securing Azure Functions, from securing the front-end endpoints themselves to securing the resources they talk to. Today, the way that works is generally you go ahead and store your connection strings inside of app settings. App settings themselves are encrypted at rest and stored when they're not loaded into memory, so they're only loaded into environment variables once the actual runtime gets spun up in the first place, so there's not any major security concerns there. We are looking at going ahead and doing a Key Vault integration later this year, so that way you can use Key Vault to manage your secrets, but it's not going to actually do anything for additional security. It's still encrypted, but it will make it easier to manage your secrets in one spot across all of your functions. So that's the reason we're going to move to Key Vault. It is encrypted at rest right now. Yeah. Yeah, everything inside of the data center is HTTPS. Or secured with SSL somehow. Any other questions? Yeah.
I was surprised when you mentioned that it was like sub-second latency was kind of your target. What if you're driving like higher speed UIs? I'm hearing a lot about Cosmos DB and their millisecond latencies they're talking about. Is there another technology you recommend if we're looking for higher speed latency for things that are driving screens and processing very fast real-time events, as opposed to, it sounds like this is more background processes. When I click this, it kicks off something later. So what's the real-time interactivity event for serverless?
So in that particular case, you're totally free to use something like Azure Functions. Azure Functions latency is going to, after you get past the first execution where it warms up the function, those are going to go ahead and be, as low as like 50 milliseconds or less.
So that's using functions directly as opposed to Event Hub. That you're saying the Event Hub brings in a little bit more latency?
Event Grid right now has more latency. They are shooting to bring that down really, really, really far. And that's just to dump the message in there. It's not going to do request response for you. So if you're looking to do request response, then you need to use something like Functions, which has a request and response pattern. Event Grid is just post. That's all that it does.
Okay, because we're trying to get a feel for which pieces get used in which application. What are the use cases?
In the case of something real time, I'd use something like Functions with traditional Redis cache thing that I'm using for caching stuff, and then going to Cosmos DB to actually go ahead and have like the more persistent store.
Okay, that clarifies a lot. Thank you.
So as far as I understand, you can trigger a function by an HTTP endpoint. So a get a post is an event, right?
Yeah.
How do you return content?
If you want to go ahead and return content, you can go ahead and very simply, I'll just go ahead and switch to machine here. I'll show you an example from the trivia example. I can go ahead and pull up my game function here, and I've got an index.js inside of here, and just to kind of shrink everything down. This thing's it's calling my trivia library, which is running the game. And then I'm just going ahead and looking to see whether or not the method is equal to post. And then I'm responding by setting context.res and then body equal to some content. If I want to change the header for like what the content type is, all that stuff is free to me. I can go ahead and just do, in this particular case, I would do headers, and then I would go ahead and pass an object to it, and then it would work like that. I can also go ahead and change the status code by just doing status and then changing that to something like, in this case, it'd be 200 for being successful.
So the function call is basically not async in regards to the incoming event.
No, you can do request response.
I can do request response.
You can do request response. That's what the context.res object is.
Okay.
In the case of C#, you can just return an HTTP response message.
So it is basically possible to build your regular user, person, human type facing website using functions.
And that's exactly what this particular demo was with the game show, is this is actually calling functions APIs
as opposed to like a REST API based.
Exactly. So in this case, this one is just calling, this is running as a separate spot, but I'm actually calling localhost 7071, and if I hit like game, it will actually return to me the current game state. But I shut down the host, so I think it won't actually run.
Thank you.
That. And now it's up and running, so if I hit refresh, you can see that I get a bunch of response there for what the current game state is. I didn't set the content type correctly, so it's not rendering it nicely, but it's responding game ID 1, number of questions 6, per question 1, answer.
That's JSON.
I think it's getting translated to something different because
not HTML.
If I don't set the content type explicitly, we'll obey what the requested content type is. And in the case of Chrome, it gives weird requested content types. So you always want to explicitly set it if you are worried about that. So in the case of my client right now, the actual game, The game is actually requesting a content type of JSON, and so I'm sending it back JSON because it wanted JSON. But we'll actually be smart and translate your object into JSON, XML, or just regular text plain in the event that you don't give us anything we can recognize.
Understood. So other than JavaScript, what languages are there?
C# and F#. And then we have experimental support for Python, PowerShell, Batch and Bash, and PHP. And then relatively soon we'll have some Java support as well.
Okay, thank you.
We do have some plans for Go. Some interesting things that we're working on in the 2.0 runtime. We have a much more extensible way of adding languages, and we're actually hoping to eventually open that up for community to add their own languages. We have plans to support it yourself, and then from there we'll build on top of that to go build the rest of the languages. And we actually rebuilt JavaScript in 2.0 on top of this platform. And so we're starting with ourselves, then we're going to open it up to everyone, and then we'll start getting back to building languages again. Very, very soon, but generally we're quality-driven, not date-driven, so it ends up kind of being we deliver it at the closest big event like this that it's done enough for. Yeah.
Just wondering, is there any integration with Pivotal on this one or Cloud Foundry for this one?
In this particular case, no.
Right. Are there any publicly available functions that we could use, whether it's open source or readily available functions? You might have mentioned that. I kind of missed it.
If you want to see all the various stuff we've open sourced on functions, samples, and things like that, we have a lot of links if you go to our main GitHub repo, which is github.com/Azure/Azure-functions. And then that is basically a hub repo, which points at all of our code, all of our samples. There's actually no code inside of that one. It's just docs. Okay. And then it points to all of our code, all of our samples, et cetera.
That's just yours, right? I mean, there's no initiative around open source or
I think it has a wiki which points to some of the other things. We also have a YouTube channel which points to all the videos that we find when we just search for YouTube or things along those lines. And you can, if you've got a specific sample you're looking for, you can always just tweet at or DM the @Azure Functions Twitter handle, and it's open for DMs for everyone. You can always respond in there, and we're Oded, he's at this conference. He's always listening for those things, and Donna and I also respond to them.
Okay. So one last thing. I think most of your services are, you're trying to make it run locally, like Service Bus or all of this. I mean, are these is that the kind of strategic vision in terms of how you're going to develop all the services that you can run locally, whether it is IoT Hub runtime or whether all of this?
I can't really speak for other Azure services. Generally, the approach for Azure is defaulted to Azure Stack as our hybrid answer. Some services have more specific hybrid scenarios in the Azure case, and some of them find use cases outside of the Azure boundary. So one example of something which isn't using Azure Stack for some of its on-prem stories is IoT Hub has announced IoT Edge coming out sometime soon. It's in private preview right now. So that has a somewhat hybrid strategy, but it's also a separate product designed for on-prem to integrate with Azure. So Azure Stack's the default strategy, and then you occasionally see more specialized strategies as we experiment with different other use cases.
And actually, it depends on what you want to do also. Are you trying to actually deploy on premises, or do you want a development experience that is local on your machine? Because the latter, we have a very good story for, because Azure Functions runtime will run locally so that you can validate that this is how the cloud execution is going to be. And even for Cosmos DB, there's a local emulator that you can run locally on your machine. So if you're building apps using these two technologies, it is possible to do all of your testing and debugging locally on your machine.
Right. I mean, I think the dev story is pretty good. I mean, you mentioned.
You want Stack and
more on
on-prem deploy. Okay.
Yeah. Thank you.
Thank you.
So a couple questions. You were saying that functions intent is to replace web jobs with those, or was it app?
It's an evolution of web jobs. We don't really have any intention to kill web jobs. They're nice and happy, and it's built on a layer on top of web jobs. In fact, the web jobs repo tends to be more busy than the functions repo because we have any feature we want to go build has to get built into web jobs and then exposed through script. Script is just a layer to basically support other languages, and if that makes sense.
And the reason I ask that, we have a use case, it's in production now, but we ended up using a web job because we had to run it continuously because it's consuming a third-party WebSocket stream.
Sure.
Can that be done with function as opposed to web job, that we don't have to?
No, web jobs is still the right answer for that particular case because functions are only going to run for a predetermined amount of time in the case of consumption. On dedicated, you can run functions for forever, but it still needs to start from someone going ahead and saying, hey, run this function. So theoretically, you could try to do that thing by having an HTTP or having a queue function, which starts the thing off, starts listening on the WebSocket, and then just never finishes the function, that'd be a pretty serious hack. I'd stick with web jobs for the time being.
Okay, and then the other question is, certainly we have applications, we can apply this right now, but some of the processes need to run on-prem in production, so it would still be a derivative of a function that sits locally that responds to events on the event grid, right?
Mm-hmm. Yes, I mean, if you are trying to run things locally.
Like mixed.
There's...
Well,
yeah, so that's essentially the answer. We have the Azure Stack answer. Yeah. We do have in preview right now the Azure Functions runtime, which is a way of running the Azure Functions bits in a Windows Server environment, and we're also moving to just support regular old container-based deployments.
Okay.
And so that's one way of going ahead and trying to run your code in both places. It's still in preview right now, so just keep that in mind, but we definitely appreciate you giving it a try and giving us feedback on what you like.
Definitely, I mean, for us, being a mid-sized organization, running Azure Stack is not going to happen.
Yeah,
just
so the Azure Functions runtime right now has no cost. I'm not sure what the plans will be if we GA it, but right now it's just free.
Okay,
so.
Thanks.
Mm-hmm.
We encountered a thing where with our Redis cache, the connections were kind of getting maxed out during the scale out, and we had to do the tweak with like max thread kind of overrides. Do you picture long term that things like trying to maintain the right number of connections or parallel connections is an automatically thing, or is there going to be a certain amount of like instance level tweaking, like, hey, we need to override some stuff to make it work for us?
We don't yet have any plans for like offering any first-class APIs for managing connection pools.
Yeah.
I do plan on having a lot more samples for it. So like one thing that we're going to put a lot of effort into is trying to come up with more end-to-end samples that do have like singleton and factory type things for getting things off in the background. There's not really anything that extra that our runtime can do for you, except for just provide that API for you out of the box to do a factory, and it just we have to do it for every language, and it makes a lot more sense for us to just document the patterns. And then if we still get feedback that it's still confusing, we might then add APIs for it. But there's nothing value added there, except for maybe it would make things a bit simpler to walk up and use.
Okay, because I think it went from your example to apply to Stack Overflow, and now it's going to be fed back into, it sounds like, some more reference examples.
Yeah.
Okay.
So like, we'll hopefully go ahead and have a lot more of those samples on our docs. We've got the awesome cloud developer advocates. You might have run into them here on the thing. We're working together to go ahead and get a lot more just kind of end-to-end examples of how these things are built.
Okay, and then I put this out in the Azure Advisors Yammer thread or whatever. But as far as being able to establish a config-based ceiling on scale out, so for example, hey, we have some downstream bottlenecks that we want to avoid. Any intention on having a ceiling that you'd?
So we don't have any plans for that right now. We do have some thoughts around iterating on our current consumption plan that could be interesting to that.
Yeah.
I generally don't like the pattern of giving people the ability to go in and hard code their like max scale as a means to avoid frying something downstream. What I hope to do is in my examples that I publish for the singleton stuff, we show you how to go ahead and have your singletons recognize that it's out of leases for that particular thing. So we essentially can use like blobs as leases, use blob leases to determine how many singletons we actually allow.
Okay.
And even though functions is still trying to scale you out, essentially you'll just be like, oh no, I can't get any more connections. I'm just going to go ahead and tell functions I'm done scaling out.
Okay, I think once again, if there was kind of an established pattern or whatever, because
it's definitely a problem.
We're always like let's say you use like a queue or ballot or whatever, it's like, but then they change how that works underneath, and that starts operating differently.
And you can have a SaaS service that only accepts like 10 requests a second. Durable functions can do some things to solve it in the sense that it will go ahead and give you the sense of a singleton.
Yeah.
But it is also just really nice to just have an in-memory singleton with a blob lease, and you never have to worry about state with durable functions.
That's the thing. We don't want to break the spirit by doing some of those. Okay.
Yeah. So that's the reason I'm hesitant to go ahead and actually set max limits in consumption. But I will try to have some samples to solve that. We've helped other customers get around that using blob leases.
And then the on-premise, on a Windows server, is that like a month, half year, like factor?
To GA.
GA.
I don't know what the. Yeah, we don't currently have any timelines. It's kind of the same story. A lot of our stuff we just kind of keep on working on until it's the right quality. We encourage you to just generally follow along on GitHub, and if you really feel the heat that it needs to GA, just like focus on Twitter and stuff like that. And if we have someone who really wants something, we might go ahead and try to prioritize getting it GA'd faster.
The next step is not GA, it's more to get the Linux one.
Okay.
Yeah.
But we'd love to hear more use cases and see how much demand there is.
Yeah, for the time being, it's not feature complete. So.
I have a few questions. As far as DevOps goes, so if you ever
dev, test, prod environments, do you just recommend creating different resource groups and deploying functions in that? Since there will be a name conflict, right?
Yeah, so in this case, it can be really up to the opinions and the actual scenario. I really like different resource groups for each environment, and basically having an ARM template and a deploy command and all that kind of stuff, so I can go ahead and create new environments just on a whim. I have a new developer that wants to go test a change. They go ahead and deploy that and do that change. I've got pre-production environments that are running. Maybe I've even got some fancy stuff where I've got an API front end and I'm splitting traffic to do some blue-green stuff. I generally like going ahead and just keeping everything separate rather than trying to do a lot of things inside of a single function app. Slots are good, but they can be limited in the consumption plan since we only allow you to have one right now. And so it's really best for just trying to do a clean deploy rather than just running a test. I wouldn't use slots in consumption plan to actually have like a test environment. I'd use that as a pre-prod swap type thing and keep a separate test environment.
Second question I have is, in this other cloud provider, there is a limitation on the number of NICs you can have, virtual NICs, because there's some limit that you may reach pretty quickly. Is there any limit like that in there?
I don't know enough to say yes or no. Okay. I'm not aware of any of the limits. You can probably come by our booth and we can have you talk to our networking specialist.
Okay. And as far as Cosmos DB, do you get a snapshot of before and after of the document, or just after?
You just get the change, so you don't get the actual before. You just get the new document.
Okay. And as far as processing time, I think you mentioned something about if you want to process a log or what's the limit? 5 minutes, 2 minutes? As far as
the timeout for consumption plan is 10 minutes.
Okay.
If that's too short for you, you can switch to dedicated plans. Then you're not serverless anymore, but you have no timeouts at that point.
Okay. Okay. Thank you.
So in your experience of onboarding customers to a serverless architecture, are there any trade-offs in using a serverless architecture as opposed to a more traditional architecture?
Oh yeah, lots. For instance, you're going to basically having to learn a whole set of new technologies, and you have to program it against our opinions and our APIs. When you use something like app service, for instance, you can go ahead and deploy a Node application that's Express. That's just like any other Node application. If you use app service Linux with container support, you can just deploy a container, and that container is the same container deployed to 5 other places. And so you have a little bit of some vendor-specific things you have to kind of learn to take advantage of. And you can't use all the same techniques that you previously used. We've done a lot of work to make sure you can use your existing tools, but a lot of patterns are still very nascent, as kind of our conversation has had. That said, the point of those trade-offs, the point of those changes, is to try to take away some of the responsibility from you of actually having to understand all those pieces. And so today, I'd say if you have an existing web app that you like just fine, there's not necessarily any reason to just immediately start moving it to functions by its nature. There might be a scenario where it's like really low traffic, and it'll save you a lot of money to do that. But just because it's not really a thing. If you're starting something green, I definitely would start on functions if it can fit the scenario, just because we'll get more and more patterns as we're going along. We'll have it more standard, and it really has a lot of advantages in the long run over having just generally deployed infrastructure. And I would also look, one thing that I recommend people who are trying to hey, how do I move from like this to functions? Is I really try to remind them that we do have other things besides functions like Logic Apps and Event Grid, and finding ways of incorporating that. Once again, patterns are still evolving there, but I've just seen some really, like the Plexure, for instance, uses Logic Apps as part of its workflow that has functions plugged into it, all customer-driven config there. That is just such a powerful pattern that they didn't have to build their own orchestrator, they didn't have to go build any of those pieces. It was just there for them, and they built all this stuff incredibly quickly. Their team, feature-wise, just moves faster than us. It's kind of like that's kind of the impressive thing about it, because we have to build on top of servers. But that part is generally what I recommend people to think about. Is don't think about it in terms of trying to translate your web server into functions necessarily. Try to think about approaching it from a fresh point of view. How does this free me up? And it's just a matter of getting your feet wet. That's what Plexure did. They started with just one thing, and they slid down the pit into serverless land.
The other thing is, will we be able to integrate Microsoft Dynamics 365 with serverless architecture, or leverage this?
Yeah, so I mean, we'll continue to go ahead and integrate functions with all the various Microsoft SaaS solutions. If it makes you feel good there, we're in the same org as Dynamics 365, or we have the exact same VP, and so it's not only really valuable to us because we have lots of customers who want that, but we also have
by
people
the way,
who want us to do it.
Logic Apps.
It's good for my career as well.
Yeah.
Yes.
By the way, Logic Apps already provides great integration with Dynamics.
I see. Okay.
So, and if you want to write custom code, yeah, in functions also, it's going to be.
Exactly.